Welcome back to another episode of High Output Juice. Yes, that's how it's pronounced. Get your mind out of the gutter. In this series, we are looking at power consumption of various Milwaukee tools. Today, what we're going to look at is the Milwaukee Rover Servile Reparations Floodlight. It's model number 2367. And we are going to test a variety of batteries. Got a 2.0, a 3.0, and a 2.5, a 4, and a new 5.0 high output, a couple high outputs in there. I'm going to run a series of tests. I got 3 tests planned for this light. The first test is to hook it up to a multimeter with some battery equipment I've cobbled together and measure how much current this light draws. And I got a light meter as well, and we'll see whether these batteries, do they make any sort of a difference insofar as power consumed and light output. Well, that's going to be the first series of tests. The second series of tests is going to be looking at, well, I'd like to verify my normal methodology of measuring current from Milwaukee tools. I use a clamp meter on this line splitter. I don't know how reliable this is. I imagine it's reliable, but this time we're going to actually find out, because this being low current draw, we can actually measure the current with this high accuracy multimeter, and we'll see whether the power, the amperage, the current indicated in this window doesn't match the current in that window. So that'll be the second test. And then in the third test, what I'm going to do is simply hook up the lowest capacity battery I got here, the 2.0, and we are going to let it drain the battery, and we're going to measure what happens with the voltage. The voltage will go down as the battery's drained down, but does the light output stay the same, or does the light output, does it decrease as well? Well, let the tests begin. For the first series of tests, we got the light here mounted in a hobby vise. We got volts for the battery here, current displayed here, and we have light in lux indicated here. Note that this isn't really a meaningful measurement because, well, my shop is brightly lit. But at least what this will allow us to determine is whether light output, whether it varies from one battery to the next. If you would like me to do a more in-depth video where I see light output of this Rover light using this meter, leave a comment down below, and if I get a handful of likes, maybe I'll think about doing a video. Anyways, the first test, we are going to put in the CP 2.0. CP 2.0 is registering 11.9 volts, and now let's try the Rover on high mode. Let's stabilize. Now we're going to try it on low mode. Let's stabilize. Turn it off, and let's see the parasitic draw if this USB key was accidentally turned on the USB circuit. Okay, that would be USB parasitic draw if we were to accidentally turn that on. Now, let's try the next battery. Next battery up is the CP 3.0. We're reading a little bit higher voltage. High. Low. Off. And once more, we'll try that USB and see what the parasitic draw is. Okay, that's CP 3.0. Now let's try the new high output 2.5 battery. Okay, 12.1. High power. A low power. And off. Now, let us try an XC 4.0 battery. 12.1 again. High. low, and off. And lastly, we're going to try my new fancy high output 5.0, which performed very well in the impact driver. On high. On low. Nope. Light meter turned off. And off. That completes test series number 1, and let me just go and crunch the numbers, make some graphs. And the results are in, and the results are as expected. It doesn't matter what sort of battery you use, whether you use a low power 2.0 or the latest, greatest high output 5.0. The amount of current draw, the amount of power drawn from the batteries is about 6.1 on high power, about 1.7 watts on low power. And the amount of light that's being output from the light, it remains constant regardless of what the battery voltage is. This 2.0 is reading a little bit low and the rest of the batteries are a little bit higher, but the light output remains the same. Well, next thing that we can do is we can verify Milwaukee's marketing claims. Milwaukee claims that this light gets 8 hours of runtime on high power with the XC 4.0. Well, we found that this light consumes on high power about a half an amp. A half an amp divided into 4.0, that gives 8 hours of runtime. Not too bad. For low power, Milwaukee claims that this would get 24 hours of runtime on low. And we measured a little less than 0.15 of an amp being drawn, and that would translate into a 4.0 providing a little bit longer of a runtime, maybe about 26 hours. So Milwaukee's being a little bit conservative with their marketing there. So what we find is on high power, for every half an amp hour, you get 1 hour of runtime on high, and for every half amp hour on low, you would get about 3.5 hours of runtime with this light. Activated, the USB circuitry idles at around 0.018 amps, and Milwaukee states that it'll shut itself down after 2 hours, meaning that we consume about 0.036 amp hours from a battery. From this CP 2.0, that would be about 2%. For this next test, I am going to see how accurate this clamp meter is compared to a directly connected multimeter. Sorry about the display being upside down, can't help that too much. Let's set it up to DC, and when it's in DC, it's sometimes not at 0, and it's possible to get it closer to 0 by pressing the 0 button, and there we go. Now, even once it's been zeroed, it fluctuates a little bit. Let's try the lamp at high power. And at high power, it is drawing 0.507. And this clamp meter is actually fairly reasonable. However, that last digit's jumping around a little bit. That last digit might not be too reliable. That would be about under a tenth of an ampere. Okay, let's try a lower power. Now we're reading 0.143 there, and you can see at low power the clamp meter, low amperage, the clamp meter is no longer quite as accurate. It's actually floating around roughly around the right value. For higher power rating, higher amperage, higher current, clamp meters, that's where they shine. These multimeters, they only go up to 10 amps typically. So anything more than 10 amps, you got to use a clamp meter. And most Milwaukee tools do draw well above 10 amps. And for the last test, I got the CP 2.0 installed, and it's on high power. Light meter, the reading's a little bit different because it shifted a little. got the voltage monitored, got the current monitored, and we're going to let the battery run out, and we're going to see what the discharge is like and whether the light output changes depending on, well, we'll see what happens. So the Rover started with consuming 6.1 watts of power for a couple of minutes. Thereafter, the power draw from this 2.0 battery had fallen to 5.1 watts, and it remained at that level for the entire duration of this test, except for one little blip at the 2-hour mark. That was my fault. I pressed the on and off button to cycle it, and I wanted to see what the battery gauge was reading. The fuel gauge, it read 1 LED at that time. Anyways, the light output of this lamp, it remained constant throughout the depletion of this battery, all the way from its original voltage down to 10.2 volts. At that point, we started getting a warning flash, about a couple flashes every minute or so, indicating that the battery was at the end of its usable cycle. I ended the test there because I found that to be really irritating on a job site. That might even be a little bit on the dangerous side. It was flickering like a strobe. So yeah. This battery that I chose for testing, it is a 2.0, but it's a little bit of an older battery. I wanted a real-world test. This battery is about 3 years old, and in a previous video I found that it wasn't working at optimum conditions. But I would consider it to be about an average battery. It's about 3 years old, and it's been through a handful of cycles. I'd say it's about halfway through its usable life. I got 3 hours on it. Not like how we would calculate a new battery. You take the amp hours, you multiply that by 2, and it should give us 4 hours of usable light. Your mileage may vary. Anyways, I hope you found this useful. Thanks for watching. Take care, and bye-bye.